Hello, welcome to Impulse Mathematics. I'm Shubhajit Bukshi. In this session, I'm going to discuss the introduction of differentiation. So, previously I discussed about the concept of differentiation. If you don't see the video, I have linked it in the description. So, before going to start, I suggest you to hit the bell icon to get notified every time I posted a new video. So, without wasting time, let's get started. So differentiation is nothing but a change of a parameter in some particular interval. If I consider a function y equal to fx, mm, like here, that is y equal to fx curve, and if I consider a point P here, and after a small interval of h, if this point going to this, that is q a plus h and f of a plus h coordinate, and the coordinate of P is a and fa, then here we see that the after a small interval of time, the coordinate of q going to a plus h and f of a plus h. So the rate of change with respect to the interval h is nothing but this f of a plus h minus f of a by h. That is, so now if we consider this interval is very small, that is h tends to 0, then we denoted f dash a. We denoted this as f dash a and defined this as f dash a equal to limit h tends to 0, f of a plus h minus f of a by h. So here I am considering a problem from NCERT exercise 13.2 question number 1, that is find the derivative of x square minus 2 at the x equal to 10. That is, we have to find out the rate of change of this function x square minus 2 at the point x equal to 10. So we denoted this as f dash 10, and if we put the formula here, that is limit h tends to 0, f of 10 plus h minus f of 10 by h, and putting these values like that, and after simplifying we'll reach at h tends to 0 20 plus h. So if we simply putting h equal to 0 here, so we get the value is 20. So now I am going to discuss the geometrical interpretation of derivative. So if we consider the function y equal to fx like that, and the point P has a coordinate a f of a, and after a small interval h, the point is here, that is q a plus h f of a plus h, then, and also considering that the chord PQ joining here, and the tangent at P makes the angle psi with x-axis in anti-clockwise sense, so then we'll get f dash a equal to h tends to 0, f of a plus h minus f of a by h. And if we consider triangle here, that is Q, P and R, then we see if I take the point Q as h tends to 0, then a plus h f of a plus h is going to be f of a, that is nothing but P. So if we consider this triangle QPR, then the tangent is QR by PR, and here the angle is psi. So here we consider the triangle PQR, and the ratio of the limit we are taking precisely equal to tan PQR that I discussed, which is the slope of the chord PQ in the limiting process as h tends to 0, the point Q tends to P, then limit h tends to 0, f of a plus h minus f of a by h is limit Q tends to P, QR by PR. That is, if the point Q is going to here, then we write this as limit Q tends to P, QR by PR. It is equivalent that the fact that the chord PQ tends to the tangent at P. This chord PQ is nearly about the tangent this, so the limit turns out the equal to the slope of the tangent, here f dash a equal to tan psi. For a given function f, if we consider this as a every point, if for a given function f we can find the derivative at every point. If the derivative exists at every point, then it define a new function called derivative of f. Then previously I considered this derivative at the point, but here I taking this point as a function. If we suppose f is a real valued function and the function is defined by limit h tends to 0, f of x plus h minus fx by h, this function is whenever this limit exists, then this is called the derivative of f at x and is denoted by f dash x. This definition of the derivative is also called the first principle of derivative. This is noted as f dash x equal to limit h tends to 0, f of x plus h minus f of x by h. Clearly the domain of definition of f dash x is whenever the above limit is exist. Sometimes we denoted this f dash x like ddx of fx, and for y equal to fx, f dash x equal to dy dx, and this is read as derivative of y or fx with respect to x. Here I consider another problem, NCERT 13.2, question number 4.3, that is find the derivative of fx from the first principle, fx equal to 1 by x square. We know that f dash x equal to limit h tends to 0 f of x plus h minus fx by h. If we put the value here, then it is like that, that is limit h tends to 0 if 1 by x plus h whole square minus 1 by x square by h. By simplifying this, we will get limit h tends to 0 minus 2x minus h by x square into x plus h whole square. By simply putting h equal to 0 here, we will get minus 2 by x cube. That is a simple calculation here. So that's all for today. I'm going to discuss a new method to finding the derivative of the function easily. Then thank you for watching.